Hi everyone, this video is on the mixed exercise 12 question 27. We have a wire which is bent into the plane shape ABCD as shown. The shape that we have here is made up of two smaller shapes. So one of them is a rectangle and the other one is a semicircle as it's stated here. So the area of the region enclosed by the wire is r meters squared, and the length of AE is x meters. So AE is here, so it's x meters. And AB is equal to ED, which is the width, and that is equal to y meters. So, right. Now that we have both x and y, which are the length and width of the rectangle, it says the total length of the wire is 2 meters. So the total length, it's important to understand that it's another way of saying the perimeter of this shape is equal to 2 meters. So let's write that for now. So part A says find an expression for y in terms of x. Okay, so part A might seem confusing, but it's actually simpler than it seems, because we just need to use this value of the perimeter and then write an algebraic expression for the perimeter. Then if we rearrange that, we basically have an expression of y in terms of x. So basically the perimeter is equal to just the sum of all the sides. So y plus x plus another y. And then for this semicircle, we need to use the formula of the perimeter of a circle. So remember that we can find the perimeter of a circle by is 2 pi r, and r is the radius. So in this case, remember that x is equal, basically the radius of this semicircle is equal to x over 2, because the diameter, which is BD, is equal to AE, and that is x. So the radius of the circle is equal to, let's show that with r, is equal to x over 2. So considering that the formula of the perimeter of a circle is 2 pi r, so in this case, the perimeter of the circle is equal to 2 pi times x over 2, which gives us pi x. But remember that this is a semicircle, so we also need to divide this by 2 when we are including that into our formula of the perimeter of the shape. So for the part that is for the semicircle, we divide the perimeter of the circle by 2, and that means we get pi x over 2. And this is equal to 2, by the way, because as we mentioned above, 2 is the perimeter. So now we just need to rearrange this and make y the subject. So we get 2y is equal to 2 minus pi x over 2 minus x. And let's divide every term by 2. So we get 1 minus pi x over 4 minus x over 2. And this is an expression for y in terms of x from part A. So in part B, we want to prove that r, which is the area of the shape, is equal to this expression. Okay, so part B is very similar to part A, but this time we need to find the area. So the total area is equal to the area of the rectangle plus the area of the semicircle. So for the rectangle part, the area is simply x times y. And then for the semicircle, the area is equal to, so the area of a circle is equal to pi r squared. But again, it's a semicircle, so we divide that by 2. So we do a half times pi times r squared. So again, r is equal to x over 2. So we have x over 2 squared. So that's the radius squared. Okay, so we have this expression for r, but it's not the same as what the question is asking, right? So as you can see, one of the biggest differences here is that in the expression that we have found, we have x and y, whereas in the given expression there's only x. So that means we need to find a way to get rid of the y. And the only way and the best way here is simply because we have already found an expression for y in terms of x, so we can use that and substitute that into the y's into this y in this expression, so that we only have x for the radius part. So we can rewrite this as r is equal to x times, and then for y we write 1 minus pi x over 4 minus x over 2 plus. So in this case, we can simplify this expression. So we have x squared over 4, which becomes x squared pi times 8. Okay, so at this point, one thing that we can do is that expanding this bracket and then maybe simplifying later. So that's one approach. In this case, let's expand that. So we get x minus pi x squared over 4 minus x squared over 2 plus x squared pi over 8. So we need to factorize this. And so since the given expression has a factor of x over 8, so we take a factor of x over 8, and we are going to get then x over 8 times 8 for the first term, and then for the second term we have minus 2 pi x, because at 2 and 8 simplify, and then we have pi x squared. So for the next term we have minus 4x, and finally for the last term we just get x pi. So let's see if we can simplify any of these terms. So we have pi x, so we can simplify that. So r is equal to x over 8 times 8 minus 4x minus pi x. And that's exactly what we wanted to show. And finally, part C says that given that x can vary using calculus and showing your working, find the maximum value of r. So in order to find the maximum value of r, we just need to differentiate r with respect to x, and then set that equal to 0 so that we can find the maximum value. So in this case, maybe it's better now to expand the bracket, because we are going to need that for differentiation. So we first get x minus x squared over 2, and then minus pi x squared over 8. So let's differentiate with respect to x. The r by dx is equal to 1 minus, so we get simply x, then minus pi x over 4. So we set this equal to 0, and we are going to have 1 is equal to x plus pi x over 4. So let's multiply by 4, so we get 4 is equal to 4x plus pi x, and then take a factor of x. So let's do the rest here. So we take a factor of x, and we have 4 plus pi is equal to 4. And finally, x is equal to 4 over 4 plus pi. And so that's basically the value that maximizes r. And all we need to do to finish the question is that we need to find the maximized value of r. So that basically means substitute that value we found into the formula here to get the value of r. So we want to find the maximized value of r when x is equal to 4 over 4 plus pi. Then the value of r is equal to 2 over 4 plus pi. And so this is the maximized value of r. Okay, that's it for this video. Thank you for watching.